All right, let's walk through the code of making the graphs for the critical review. First, you're going to do what's called loading your libraries. Think of libraries like different apps, and RStudio is kind of like a phone. You have to install the app, but you still can't use it unless you open it. So we're just sort of opening these packages we want to use. So first, you're going to read the data into R. This just means that you're taking the data from the Excel file and kind of uploading it to R in a way, or just making it something that RStudio can work with. Now we're just going to create a variable called data. So we're going to take this data sheet up here that we just read in. We're going to take it right here and we're going to pipe it into different functions. This is a pipe in R, and you take something and when you put it into a pipe, it feeds it through and then comes out on the other end. So we're taking this data sheet that we just read in, and then we're going to pipe it into this function. So it's saying, okay, do all the stuff that came before it, and now do this. So the first thing we're going to do is rename the columns. And this is just so they're easier to type and more consistent with uppercase versus lowercase and things like that. With this one, we have to use backticks because the original column name has a space. And the backtick key should be right above the tab key on the left side of your keyboard. It's different than an apostrophe or a single quote mark. Okay, so we finished renaming. So we're going to pipe it now into a filter. Filter lets us choose specific rows that meet a certain condition. So you don't have to worry too much about what's inside of here. It just means that we're just keeping all of the normally scored articles. So excluding reviews, or if things are blank, we just want ones that we can include in the analysis. So once we finish with that, we pipe it into the next step, which is select. And select is kind of like filter for columns. So we're just choosing the columns that we want. Okay, and then we're going to pipe it into something called mutate. Mutate lets us create a new column or modify an existing one. You can see right here, this column pub year actually already exists, but we're just making sure that they're all numbers so nothing funky is going on when we analyze it. And then finally, we're going to filter out anything that has a blank publication year. So exclamation point is.na just means it's not allowed to be NA or blank. So then you write your intro, introduce the dimensions and scoring criteria, and then we get into our visualization and analysis. So the first graph we're going to make is this causality versus external validity plot. It looks like the title got cut off right here, so I'll have to go back and fix that. But this lets us see which specific papers are in the clusters of causality and external validity. Like this cluster right here, you can mouse over each point and it'll tell you the paper that is in that cluster. So we're going to create something called an object, which will just allow us to save it, basically. So this arrow says that everything on the right side of this arrow, you're going to put into this object, this causality and validity thing right here. So ggplot is just kind of the framework we use to start building the graph. So you specify data, and this data right here will be whatever you saved it as up here. So if you called it scoring or scoring underscore data or something like that, then that's what you would put right here. Okay? And then you write aesthetics, which just tells you what variables are being plotted in each part of the plot. So our x-axis, we want to be causality, and this factor levels just means that we want it to be in order from 1 through 6. Then we do the same thing for y with external validity, and then fill is specifying the color of the dots. So in this case, we want the color of the dots to match the publication year or tell us how old the paper is. And you can see that down here. The lighter ones correspond to more recent papers. That's what that fill does. This text equals paste, and then all of this weird looking stuff. This just tells the computer what to show when you hover your mouse over it. Now we actually are going to make the dots. So you use geom_point, and then shape and color and stroke and everything are just kind of different design choices, just how you want it to look visually. And then this position quasi-random is just a fancy way to say, don't plot them all right on top of each other. Spread them out a little bit so we can see each one individually within the cluster. This scale fill argument allows us to use a specific color palette that someone else created. Another really good thing about using this Viridis package is that the graphs are still interpretable for people with color blindness. And then labs is short for labels. So you type what you want to label equals, and then in quotes, whatever you want the label to say. So you have title, X, Y, this labels the axes. Subtitle just shows up right underneath the title. And then fill is going to show up as the legend. Right here you see publication year, and then it's saying, okay, we're filling the dots by publication year, so that's what it's titled right there. And this theme minimal just kind of gets rid of some extra grid lines and marks and stuff that we don't need. Then this is really cool. This package called ggplotly takes everything we just did and makes it interactive. So instead of just having a graph that you just look at, you can actually mouse over it and it'll tell you the different papers. You can zoom in or download it as an image so that it's not interactive anymore. But now you've created your interactive graph. Okay, now for this bubble graph, a lot of the code is pretty much the same. So we'll just go over a few things that are different. The first one is this size equals n. So instead of saying, hey, make each dot filled with a different color based on publication year, now you're saying make each dot a different size based on how many papers are in that cluster, which we calculated up here. You count each grouping and then call it n. And then you have this graph that allows you to see how many papers are in a specific causality and external validity combination. Okay, the last graph we're going to make is this histogram bar chart of robustness and transparency. So we're going to save it in hist data. So we're going to take the data or whatever you called your data up at the beginning, and you're going to pipe it into Mutate, which again allows us to change an existing column or create a new one. And so we're just going to double check that these data types are correct. Like if you've used Excel and it tries to format a dollar amount as like a date or a time, then it messes with your calculations. And so we're just making sure that each variable is the correct type. And then this arrange command just is telling it how to sort the data points. So we're going to say, okay, first sort it by robustness. And then if it has the same robustness, then look at the publication unit. And then this chunk, the group by and the mutate and the ungroup, is just making it so the dots are stacking on top of each other instead of overlapping. Then again, we use ggplot, and then our data is hist data or whatever you called this object up here. And then it's just kind of the same thing. Scale x discrete drop equals false just means that even if no papers are in that robustness score, we still want to keep it on the graph. Then add your colors and your labels and clean things up. And then just like the other two, you'll pipe it into the ggplotly for an interactive graph.